In this lesson, we're going to learn to simplify algebraic expressions. We're going to apply the order of operations principles that we've learned and apply in working with numbers. We're going to learn what's meant by like terms and how to combine like terms. And then we're going to apply properties of real numbers to algebraic expressions to help simplify them. A simple algebraic expression is, for example, 3x. 3x is what we refer to as a monomial. It's an algebraic expression that involves only variables, constants, and products. It does not involve addition or subtraction. A polynomial is an algebraic expression such as 7x minus 4, 3x squared minus 2x plus 3, or 2x minus y. These are polynomials. This is a monomial. To simplify an algebraic expression means to combine terms so that we have a sum and difference of the minimum number of monomials in that algebraic expression, or the minimum number of terms in that algebraic expression. For example, if I have 2x plus 3 plus 7x, that's an algebraic expression. It has three terms, three monomials, 2x, 3, and 7x. 2x and 7x are like terms because they have the same variable in them. So we can combine like terms and write this as 9x plus 3. This can be written in no simpler form, so this is what we mean by simplifying that algebraic expression, 2x plus 3 plus 7x. The process of simplifying algebraic expressions involves the properties of real numbers. The algebraic expression is a representative of a real number, so all of the rules and properties that accrue to real numbers are applicable to algebraic expressions as well, in the terms of algebraic expressions. In this problem that I have shown here, we have an application of the distributive property. The distributive property is A times the quantity x plus y is the same as the product of A and x plus A and y. We're distributing the multiplication over the addition. So this is the distributive property of multiplication over addition. We apply this to this particular problem, and we have 2 times s plus 2 times 3, which is 6, plus 6 times s, and plus 6 times a minus 4, which is minus 24. We learned this as a positive times a negative is a negative, plus 1. The next step, which we applied without calling it such in previous examples, is to apply the commutative property of addition. The commutative property is that it doesn't make any difference which order I add. That is, A plus B is equal to B plus A. I can switch them around. Applying that in this example then, 2s plus 6 is the same as 6 plus 2s. Now I have the sum of these four quantities, and the associative property is the property that I can add these in groups of 2 if I so choose. So for example, 6 plus 2s plus 6s, I can write as 6 plus 2s plus 6s, which is equal to 6 plus 8. Can now then write 6 plus 8s minus, applying the associative property again, I can combine minus 24 and 1 and write that as a minus 23. Now I'm applying the commutative property again to write this as 8s plus 6 minus 23. The commutative property of addition allowed me to switch the term 8s and the term 6. Apply the associative property again, combining those two and writing this as 8s minus 17. So I have 2s plus 6 plus 6s minus 24 plus 1 is equal to 8s minus 17. Practice some additional problems. Study these properties of real numbers. Practice some additional problems simplifying algebraic expressions that are more or less complex, and associate each step with one of the properties of real numbers. I may give you a problem such as this on the midterm exam, in which I ask you to simplify a rather complex algebraic expression, and at each step cite the property of real numbers that's applied in that simplification process.